Okay, so today we are starting a very important topic of integration under section 7.7, that is definite integral. It is different from indefinite integral. Okay, so in this topic of definite integral, at first we understand what is fundamental theorem of calculus, area function. There is two fundamental theorem of calculus. First fundamental theorem of integral calculus and second fundamental theorem of integral calculus. Definite integral is different from indefinite integral. There is many different thing. We relate definite integral with indefinite integral. To calculate definite integral, we have to know how to find the indefinite integral. When we find the indefinite integral, then we can calculate the definite integral. Okay, then we relate definite integral with area function. At first we know what is area function, and there is two most fundamental theorems of calculus, that is first fundamental theorem and second fundamental theorem. Okay, so what is definite integral? We already know what is indefinite integral. At first, just read the definition. A definite integral is denoted by integral a to b fx dx, where a is called the lower limit of the integral and b is called the upper limit of the integral. So there is a difference with indefinite integral is that when we integrate the function fx dx, that is integration of fx dx, but there is a difference. There is a and b. So what is a and what is b? Now there is a boundation. For example, if fx is a graph, any function can be plotted as a graph. So let's suppose fx is a graph. So when we integrate a function from a bond, from a limit, a lower limit to upper limit, there is a first one that is called lower limit, that is a. So when we integrate a function fx from a limit to other limit, then it's called definite integral. So here we integrate fx from a to b. So a is called the lower limit and b is called the upper limit. Another difference with indefinite integral is that when we integrate any function in indefinite integral, the answer is again a function. For example, if we integrate integration of x square, it become x cube by 3 plus constant of integration, that is a function. But when we integrate definitely, it means when we integrate x cube with a limit, that is integrate x cube from 2 to 3, then integration from 2 to 3 x cube, then it is not a function, it is a numerical value. Okay, so in definite integral, the value of this definite integral is a numerical value, and in indefinite case, the value of integral is again a function. That is a major difference. Okay, so here is a is called lower limit and b is called upper limit, and we read it as integrate function fx from a to b. Okay, the definite integral is introduced either as a limit of sum or it has an antiderivative f in the interval a to b. We can understand definite integral as a limit of sum, or it has an antiderivative f in the interval a to b. So what is antiderivative? We can say antiderivative is a indefinite integral, but there is a slightly difference is that when we calculate indefinite integral, the value is, for example, if we calculate integration of x, then it become x square by 2 plus constant of integration. But antiderivative is just that function. That means antiderivative of x, that is integral of x is x square by 2. Then x square by 2 is antiderivative. So antiderivative is a indefinite integral, but indefinite integral is a collection of all antiderivatives. For example, if we integrate, if we integrate x, then we get x square by 2. So x square by 2 is antiderivative is x square by 2, that is a integration of x. So but we can also write it as x square by 2 plus c, that is constant of integration. So x square by 2 plus 2, x square by 2 plus 3, any constant, all are the collection of antiderivative indefinite integral, that is a value of indefinite integral. So for a function, for a particular function, there is many collection of indefinite integral because there is present a constant of integration. So when we integrate x, the value x square by 2 plus c. So in place of c, we can substitute many values. So there are collection of indefinite integral. But antiderivative is a particular function we get when we integrate a function fx. So when we integrate fx, we get an value, an antiderivative, that is f in the interval, particular interval a to b, where a is a lower limit and b is a upper limit. We understand it very well when we do an example. Its value is the difference between the value of f at the endpoint. So what is the value of indefinite integral? That is noted as integral from a to b fx. Its value is fb minus fa, where b is upper limit, a is lower limit. And what is f? F is a antiderivative. And how we calculate antiderivative? Just integrate the function fx dx, but not mention the constant of integration. So antiderivative for function x square is x cube by 3. Okay. And the value of definite integral is fb, that is function antiderivative value at point b, that is upper limit, minus the value of antiderivative at point a, that is a lower limit. So if we want to calculate definite integral, at first we have to find the value, what is antiderivative. For this, we have to integrate the function fx as we do in indefinite integral, and then just find the value of fb minus capital fb minus fa. Okay. So next topic is area function. So what is area function? As its name suggests, it is a function of area. Okay. So we have defined that definite integral from a to b fx dx as the area of the region bounded by the curve y is equal to fx, the ordinates x is equal to a and x is equal to b, and x axis. So when we see the figure, we can understand better. X axis, y axis, and it represents a curve of y is equal to fx, and area function is denoted as capital AX. So the integral a to b, definite integral a to b fx dx is the area, the blue shaded region bounded by the curve y is equal to fx, the line curve y is equal to fx, first line, the ordinates x is equal to a, first line, x is equal to a, that is parallel to y axis. Then and x is equal to b, second line parallel to y axis, the last line, and x axis, horizontal axis. So the area bounded by this curve, the whole blue region, that is the area calculated by the definite integral. So that is the biggest application of a definite integral. By using the definite integral for any curve fx, we can calculate the area bounded by the curve and its lower limit and upper limit and x-axis, that is horizontal axis. That is very useful application of a definite integral. We can relate definite integral with area of the region bounded by the curve and its ordinate, that is its lower limit, upper limit and horizontal axis. Okay. Let x be a given point in AB. AB is our domain. We define a function fx from A to B. We know what is the domain, the function where we define it. If a function defined from A to B and A is a subset, A is a set. So when we function f defined from A to B, the set A is called domain and the set B is called codomain, and set of all images of function is called range set. So here the function, the interval A to B is our domain where the function fx is defined. So then x be a given point in AB, as we can see in figure. In the x-axis there is a x, then definite integral from A to x, not from A to B. Here the upper limit is x and lower limit is same A. So the definite integral A to x fx dx represent the area of the light shaded region. Light shaded, we can see in figure the light shaded region part, that is denoted as AX. Okay. In other words, the area of the shaded region is a function of x. So what is area function? Area function is defined as a definite integral from A to x. If we define Ax, where x is a point in that domain, that is in point in AB interval, then the area function is a definite integral from lower limit A to upper limit x fx dx, that represent the area of the that region. We can see in the light shaded region, that is area from A to x, that is the line x is equal to A parallel to y axis, the line parallel to line x is equal to B, that is line parallel to the area of the light shaded region is, can we consider the area of the line x is equal to A, the first line, x is equal to x, that second line, and the curve from A to x. That area represent the area function Ax for a particular value x. And here it is assumed that fx is greater than 0 for all x belongs to A to B. That sign is considered as belongs to. It means x coming from the interval A to B. And fx is greater than 0. It means fx always lies above the x-axis. The value of fx is always positive when x comes from A to B. For example, if we consider the function x square and the interval defined from 2 to 3, so 2 to 5, so whatever value we take, for example, if we take 2, then the value of fx is 4. If we take the value 3, the value of fx is 9. If we take 5, then it becomes 25. but it's always positive. It means fx greater than 0 for all x belongs to AB. It is necessary to define a function, area function. In other words, the area of the shaded region is a function of x. It means if we change the value of x, the area is also changed. So the area is a function of x. We denote this function of x by ax. Okay. So till now we understand what is definite integral. Definite integral is just an indefinite integral, but there is lower limit, upper limit, and at first we calculate the indefinite integral without the constant, that is also known as antiderivative, and then we calculate the value of fv minus fv minus fa, that is your definite integral. And secondly, we understand that definite integral can be related by the area of the region bounded by the curve y is equal to fx and its upper limit, lower limit, and the horizontal axis. And then we understand the area function. The area function is area, it represents the area from lower limit a to the point x, and if we change the value of x, we get different area. Okay, so the area function is a function of x, and we denote it is as ax. Okay, we call the function ax as the area function and is given by ax is equal to definite integral from a to x fx dx. So if we have a question that calculate the area of a function fx from 2 to 3, so just calculate the definite integral 2 to 3 fx dx. Okay, so now we see what is the first fundamental theorem of integral calculus. So statement is, let f be a continuous function on the closed interval a to b, and let ax be the area function, then a dash x is equal to fx for all x belongs to ab. That is your statement. So first keyword is continuous function. So what is continuous function? It says f be a continuous function on the closed interval ab. So graphically we can understand as when we can draw a function in such a manner we don't need to lift our pen. We can draw without a break from the interval a to b. For example, if we draw a function fx is equal to x from function 2 to 3, so we just take a straight line that go through the origin. So f be a continuous function on the closed interval ab. Okay, and ax be the area function. We just understand what is the area function. It represents the area from lower limit a to x. So ax is equal to definite integral from a to x fx dx. Then a dash x. A dash x means differentiation of a. Okay, so differentiation of that area function is equal to fx, and fx is the value of that function fx for all x belongs to ab. So in case of integral, we consider f as integrand. That means we have to integrate integration from fx dx. So fx is integrand. So when we differentiate the area function, we get the value of integrand. Okay. second fundamental theorem of integral calculus says, let f be a continuous function defined on the closed interval ab and f be an antiderivative of f, then definite integral from a to b fx dx is equal to capital Fx, the value of capital Fx from in a to b is equal to capital FB minus FA. So f be a continuous function, it means a continuous function that does not have any break, jumps or hole in a graph. We can draw a graph, a function without lifting your pen. Then the function is continuous. It means we can draw a function fx from an interval a to b without lifting our pen. Then so f is a continuous function and f be an antiderivative of f. So what is capital F? When we integrate the function f, that value without the integration of constant is our antiderivative. So we can think antiderivative as integral value. Okay. Then definite integral from a to b fx dx is equal to capital FB minus capital F A. So by using the second fundamental theorem of integral calculus, we can calculate the value of definite integral. To calculate the value of definite integral, we have to find the value of antiderivative of f, that is a capital F, and then find the value of f, capital F, at the point of b, that is the value of antiderivative at point b, upper limit, minus value of antiderivative at a lower limit. So just calculate fb minus fa, we have the value of definite integral, and it suggests that the value fb is a numerical value, it is a function value at a particular point. So definite integral is a numerical value, not a function. And in case of indefinite integral, when we calculate indefinite integral, that value is a function. Okay, that is a major difference from indefinite integral. So in other words, of second fundamental theorem of calculus is that from a to b fx dx is equal to, that means how we can calculate the value of definite integral from a to b is that value of the antiderivative f of function f at the upper limit b minus value of the same antiderivative at the lower limit a. Okay. So second fundamental theorem gives a way, that's how we can find the value of definite integral. This theorem is very useful because it gives us a method of calculating the definite integral more easily without calculating the limit of a sum. So in chapter differentiation, we know about a limit of sum. So we can calculate the definite integral by calculating its limit of sum. Okay. But by using the second fundamental theorem of integral calculus, we don't need to calculate the limit of sum. We can directly calculate it by finding our antiderivative and then the value of antiderivative at a point upper limit and lower limit. Okay. So calculating the definite integral is more easier by using the second fundamental theorem of integral calculus. Okay. So in definite integral from a to b fx dx, the function f needs to be well defined and continuous in AB. So whenever we have to calculate the function a definite integral from a to b fx dx, the function f needs to be well defined. It means it should be defined in the whole domain and continuous in AB. Okay. So what is the meaning of well defined? For example, there is a we have to calculate the definite integral I is equal to minus 2 to 3, that is the lower limit is minus 2 and upper limit is free, and the function fx is equal to x into x square minus 1 whole power 1 by 2 dx. Now we have to calculate this definite integral, and here the interval is minus 2 to 3, the value of a is minus 2 and the value of b is free. So the function should be well defined and continuous. Okay, so how we can check it is well defined or not? Well defined mean it has to define in all the points. For example, if here fx is equal to x into x square minus 1 power 1 by 2 is not defined in a portion minus 1 to 1, it means if we take any value between minus 1 to 1, then the function is not defined. For example, we take just x is equal to 1 by 2, then the value of fx is equal to 1 by 2 into 1 by 2 whole square minus 1 the power 1 by 2 is not a real value, because 1 by 2, that is 1 by 4 minus 1, so it become minus 3 by 4, 1 by 4 minus 1, so minus 3 by 4 and minus 3 by 4 power 1 by 2, that means square root of minus minus number, that is a imaginary number. So it is not a real value, it is a complex value. So the function fx is not defined in the portion minus 1 to 1. So fx is not a well defined function. So if we want to define a definite integral, f needs to be well defined and continuous. In this case, we cannot calculate the value of definite integral minus 2 to 3 x into x square minus 1 power 1 by 2. Steps for calculating definite integral a to b fx dx. At first part, find the indefinite integral, that is integration of fx dx. We already know very how to find this indefinite integral. There is a many method according to the question. So at first we calculate indefinite integral fx dx, that is capital Fx, and that is called antiderivative without the constant of integration. There is no need to keep integration constant c, because if we consider, let's say we consider fx plus c, instead of fx we get definite integral a to b fx dx is equal to fx plus c a to b. So just substitute b and a, upper limit and lower limits, that is upper limit minus lower limit. So fb plus c minus fa plus c. So plus c and minus c, it cancel out. So the value of definite integral is capital Fb minus f capital Fa. So if we consider the constant of integration, there is no need, because in the middle step it cancel out. So to calculate the definite integral a to b fx dx, at first we have to calculate indefinite integral, integration of fx dx, and then just find the value of capital Fb minus capital Fa, where f is anti-derivative. Okay. Evaluate Fb minus Fa, which is a value of definite integral a to b fx dx. So that is the two steps how we can find the value of definite integral. So the first question is, find the value of the following integral. So we have to calculate the definite integral from 2 to 3 x square dx. Here lower limit is, the value of a is 2, and the value of upper limit, that is b, is equal to 3. So we have to calculate definite integral from 2 to 3 x square dx, and the functional value, the value of function is, what is the function? X square. So at first we have to calculate indefinite integral. So what is the integration of x square? We know integration of, that is standard integral formula for integration of function xn, is that integration of xn is xn plus 1 x to the power n plus 1 by n plus 1. So when we integrate x square, here the value of n is 2, so it becomes x is equal to n x to the power n plus 1, that is 3, by n plus 1. And there is no need to add constant of integration, and that function x cubed by 3 is called antiderivative, or it represented by capital F x. Okay, so first step is complete. In the second step, by the second fundamental theorem, we get I is equal to f3 minus f2. f3, that is the value of the value of antiderivative at the upper limit, that is f3, and value of antiderivative at lower limit, that is f2. So we have to calculate f3 minus f2 to find the value of definite integral 2 to 3 x square dx. So f3 is 3 to the power cube by 3, that is 27 by 3, and f2 is 2 to the power cube by 3, that is 8 minus 3. So 27 by 3 minus 8 by 3 is equal to 27 minus 8, that is 19 by 3. Hence the value of definite integral is 2 to 3 x square dx is 19 by 3. So that's how we can find the value of definite integral. At first, calculate the indefinite integral. Then by using the second fundamental theorem, just calculate capital F3 minus F2. Okay. So from the case of indefinite integral, there is only one more step to calculate the definite integral. We have to calculate the indefinite integral without the constant of integration, that is your antiderivative, and in the next step we just have to calculate fb minus fa, and that is your value of definite integral. So find the value of following integral. Integrate from 4 to 9, that is your here the upper limit is 9 and lower limit is 4, and the function value is root under x by 30 minus x to the power 3 by 2 whole square dx. So at first you have to calculate the value of indefinite integral. Don't need to mention the constant of integration, and then just calculate that antiderivative at upper limit minus antiderivative at lower limit. I think you know how to calculate this antiderivative. So at first you try. Let us step by step solution. In first step, we have to calculate the value of indefinite integral. So we have to calculate the value of definite integral from 4 to 9 root under x by 30 minus x to the power 3 by 2 whole square dx. So we first find the antiderivative fx of a given integral and then apply the second fundamental theorem of calculus. So in first step, so to integrate root under x by 30 minus x to the power 3 by 2 whole square, we apply the substitution method. Because when we notice that when we differentiate 30 minus x to the power 3 by 2, the differentiation is a multiple of numerator, constant multiple of numerator. So we apply the substitution method. So 30 minus, when we just take 30 minus x to the power 3 by 2 as t and then differentiate it with respect to x. So differentiation of constant function is 0 and then differentiate x to the power 3 by 2. So it becomes minus 3 by 2 root under x dx. What is the differentiation of xn? When we differentiate dxn by dx, it is equal to n into x to the power n minus 1 dx. So when we differentiate x to the power 3 by 2, we get 3 by 2 into x power 3 by 2 minus 1, that is 1 by 2, that is square root. So we get minus 3 by 2 root under x dx is equal to dt. Or we can write root under x dx is equal to minus 2 by 3 dt. So our integral become root under x dx substituted as dt 2 by 3 dt, and in place of 30 minus x to the power 3 by 2 we just put t. So we get minus 2 by 3 integration of dt by t square. That is, now we have to integrate dt by t square. That is integration of t minus 2 dt, and integration of xn is x power n plus 1 by n plus 1, and here the value of n is minus 2. So when we integrate dt by t square, it becomes 2 by 3 into t the power minus 2 plus 1, that is minus 1, by minus 2 plus 1, that is minus 1. So we get minus 1 by t, and minus minus plus 1 minus 4 1 of 2 by 3. So we get the integral value is 2 by 3 into 1 by t. Substitute back t is equal to 30 minus x to the power 3 by 2. We get 2 by 3 bracket 1 by 30 minus x to the power 3 by 2, and that is the value of your antiderivative. Okay, so first step is complete. In second step, we apply the second fundamental theorem of integral calculus, that says the value of definite integral is equal to the functional value of antiderivative as upper limit minus the function value of antiderivative at lower limit a. So now we calculate f9, that is the upper limit, minus f4, that is a lower limit. So the value of f9 is 2 by 3 bracket 1 by 30 minus x to the power 3 by 2, that is 9 to the power 3 by 2, and 9 can be written as 3 square. A square is cancelled out, and 3 to the power 3 is 27. Okay. And then we have to calculate f4. So 1 by 30 minus x to the power 3 by 2. So 4 to the power 3 by 2. 4 can be written as 2 square, and 2 is to cancel out. So 4 to the power 3, that is 8. So when we simplify it, we get 2 by 3 into 1 by 3 minus 1 by 22. So when we simplify, we get the value of definite integral from 4 to 9 is 19 by 99. Okay. Example number 25 is find the value of the following integral. We have to calculate definite integral from 1 to 2 x dx by x plus 1 into x plus 2. So in the first step, you have to find the value of indefinite integral x dx, x plus 1 and x plus 2. So just think how we can calculate this integral. Okay, let's solve. So we have to calculate I is equal to integral 1 to 2 x dx by x plus 1 into x plus 2. Now, this is a rational function and we know in this such kind of question, we apply the method of partial fraction. We decompose it into a partial fraction and then find the integral value. So as x plus 1 and x plus 2 is linear factor, so its form of partial fractional decomposition is a by x plus 1 plus b by x plus 2, and then using some algebraic calculation we find the value of a and b. Okay, so the value of a is -1 and value of b is 2. We already know how to calculate this. So to find the integral value of x dx by x plus 1 into x plus 2, it become minus log x plus 1. That is the integral value of -1 by x plus 1. And integration of 2 by x plus 2 is 2 log x plus 2. As we know, integration of 1 by u du is log u. Okay, so that is the value of fx, that is antiderivative. So first step is complete. To calculate the integral value, you have to write the all step. That's how we calculate a, then b, and then term wise integration. First we integrate -1 by x plus 1 and then 2 by x plus 2, then combining this both integral value to get the value of integration x dx by x plus 1 into x plus 2. Okay, now we have a value of antiderivative. So first step is complete. In the second step, we apply the second fundamental theorem of calculus, and it says the value of definite integral is equal to the value of antiderivative at its upper limit minus the value of the function antiderivative at its lower limit. So we have to calculate capital F2 minus capital F1. So just substitute x is equal to 2 and minus then x is equal to 1 in capital Fx. So we get minus log 3 plus 2 log 4 minus into minus log 2 plus 2 log 3. So when we simplify, we get minus 3 log 3 plus log 2 plus 2 log 4. So just apply the properties of logarithmic. That is log a plus log b is log a into b, and log a minus log b is log a by b. So when we apply the properties of logarithmic, we get log 32 by 27, because log 2 log 4 can be written as we know the properties of logarithmic is that n into log a is log a the power n. So 2 log 4 is equal to log 4 the power 2. So log 8, log 16, that is power 4 power 2. So log 16, and then log 2 plus log 16, you use the property of log a plus log b, that is log a into b. So it become log 16 into log 16 into 2, so it become log 32, and then minus 3 log 3 is become log 3 the power 3, that is 27, so it become log 32 minus log 27. Then we apply log a minus log b property, that is log a by b, so it become log 32 by 27. So the value of definite integral from 1 to 2 x dx by x plus 1 into x plus 2 is log 32 by 27. So third, we have to find the value of following integral, that is integrate from 0 to pi by 4 sine cube 2t into cos 2t dt. Okay. So in first step, we have to calculate the integral value, that is integration of sine cube 2t into cos 2t dt. So we use the substitution method. So we put sine 2t as u, because when we differentiate with respect to t, we get differentiation of sine 2t is, we apply the chain rule and we get 2 cos 2t dt is equal to du, and cos 2 dt is present in the question. So cos 2t dt is replaced by 1 by 2 du. So my integral become, in place of sine 2t we put u, and in place of cos 2t dt we replace by 1 by 2 du. So my integral become 1 by 2 integral u cube du. So when we apply the standard formula of integration of un, that is un u the power n plus 1 by n plus 1, it become 1 by 2 into u the power 4 by 4, so it become 1 by 8 into u the power 4. So in place of u substitute back the value of u, that is sine 2t, we get the integral value 1 by 8 sine the power 4 2t, and that is your antiderivative value ft, capital Ft. Okay, now the first step is complete. So now we use the second fundamental theorem of integral calculus to calculate the value of definite integral, and that is f upper limit, that is pi by 4, minus f0, that is the lower limit value. So when we substitute pi by 4 in capital Ft, we get 1 by 8 sine the power 4, 2 into pi by 4, so pi by 2, minus 1 by 8 sine 4 0. So we get the value of sine pi by 2 is 1 and the value of sine 0 is 0. So the value of definite integral is 1 by 8. Okay. So today we learned about the concept of definite integral and understand how they differ from indefinite integral. Then we understand how we can relate indefinite integral with area function and what is area function, and then first fundamental theorem of calculus, and then second fundamental theorem of calculus, and how second fundamental theorem calculus is useful to find the value of definite integral. Okay, and then we do some example, so how we can calculate the value of definite integral.